Astronomers discover rare black hole devouring a star. Imagine a cosmic predator lurking in the shadows of the universe, feasting on a celestial snack. Astronomers have captured a rare glimpse of a missing link black hole in the act of tearing apart a star, a discovery that could shake up our understanding of galaxy evolution. Using NASA's Hubble Space Telescope and the Chandra X-ray Observatory, scientists identified NGC 6099 HLX-1, a mysterious object 40,000 light-years from the center of a giant elliptical galaxy in the Hercules constellation, a staggering 450 million light-years away. What makes this find extraordinary? It could be one of the elusive intermediate mass black holes, IMBHs, that bridge the gap between stellar and supermassive black holes. Black holes, the unseen trio. Black holes come in two familiar forms. Stellar black holes, born from collapsing stars and weighing up to 100 times the sun's mass, and supermassive giants that dominate galactic centers. Intermediate mass black holes, however, remain the holy grail of astrophysics. Too hefty to form from single stars, and too dim to outshine other lights. Their existence challenges detection methods. IMBHs like HLX-1 could explain how galaxies grow, says Yiqi Cheng from Taiwan's National Tsinghua University. Their extreme X-ray brightness acts as a beacon, pinning down these phantom black holes. But here's the controversy. Do these mid-sized monsters form when small black holes collide? Or do they emerge directly from collapsed primordial gas clouds? A star's fiery end. In 2009, scientists spotted an X-ray flare that blazed 100 times brighter by 2012, then gradually faded. This erratic pattern mirrors a catastrophic event, a tidal disruption. A star being shredded like cosmic confetti. The debris spirals into the black hole, creating a glowing disk that radiates at 3 million degrees. Hubble also revealed a dense star cluster orbiting the IMBH, packed so tightly that stars are just light months apart, fake 500 billion miles of neighbors. If HLX-1 is indeed an IMBH, how long does it take to digest a star's remnants? Asked Roberto Soria of Italy's National Institute of Astrophysics. Will it flare again? Or was this a one-time rampage? The answer could rewrite the rules of black hole behavior. Galaxy building blocks. This discovery rekindles debates about blacklist roles. Traditional theory suggests IMBHs merged to form supermassive giants. Others argue they formed directly from ancient gas clouds. But HLX-1's location, a galactic suburb, far from the central supermassive black hole, hints at a third possibility. Galaxies might harbor orbiting IMBHs, like retirement communities for cosmic monsters. Finding more free-floating black holes ablaze from stellar disruptions could give us a statistical roadmap. Soria adds, if we're lucky, we'll track how often these events occur, revealing the hidden history of galaxy assembly. The big questions. IMBHs may hold the secrets of cosmic architecture. Could they be the architects of massive galaxies? Or are they just curious anomalies in the dark matter jungle? One thing is certain. HLX-1's hunger offers a rare chance to study these middleweight monsters up close, proving that sometimes the universe serves up its biggest mysteries with a side of stellar debris. What's your take? Should IMBHs be considered essential players in galaxy evolution? Or are they just cosmic oddballs? Share your thoughts in the comments or search for IMBH today to dive deeper. Discovering an intermediate black hole. NGC 6099 HLX-1. Imagine a cosmic monster lurking in the depths of space, feeding on the very fabric of a star. This is the astonishing reality that scientists have recently uncovered thanks to the combined efforts of NASA's Hubble Space Telescope and the Chandra X-ray Observatory. These two space observatories, although relatively old, continue to make groundbreaking discoveries that shed new light on the mysteries of the universe. Their latest finding is nothing short of extraordinary, an exceptionally rare intermediate black hole, currently in the process of devouring a star. But here's where it gets fascinating. This intermediate mass black hole, IMBH, is a cosmic phenomenon that has long eluded astronomers, hiding in plain sight and waiting to be detected. The discovery of this IMBH, located about 450 million light years from Earth in the vast elliptical galaxy NGC 6099, is a significant breakthrough in our understanding of black hole evolution. The Hubble Space Telescope has been instrumental in the study of supermassive black holes, revealing that these cosmic giants reside at the centers of galaxies, weighing millions or even billions of times the mass of our sun. However, the existence of smaller black holes born from the demise of massive stars has also been confirmed. Yet, there is a third class of black holes that has proven to be much more elusive: the intermediate mass black holes, which are neither too big nor too small. These IMBHs are often invisible to astronomers because they do not emit the same level of radiation as their supermassive counterparts, making them incredibly difficult to detect. But when an IMBH does devour a star, it unleashes a tremendous amount of radiation, making it possible for scientists to observe this rare event. The latest discovery, NGC 6099 HLX1, was caught snacking about 40,000 light years from the galactic center of NGC 6099. The associated research, published in the Astrophysical Journal, reveals that scientists initially discovered unusual X-rays in Chandra observation from 2009, which were later confirmed using the European Space Agency's XMM Newton Space Observatory. The X-ray emissions from NGC 6099 HLX1 were a scorching 3 million degrees, consistent with the expected observations of a tidal disruption event. Hubble data also revealed evidence of a small cluster of stars surrounding the suspected IMBH, providing ample sustenance for the medium-sized black hole. The stars are incredibly close together, separated by only a few light months, or about 500 billion miles. The suspected IMBH reached its maximum observed brightness in 2012 and has since declined in intensity. But the question remains, how long does it take for the IMBH to swallow the far's gas? The study's co-author, Roberto Soria, explained that the IMBH was fairly bright in 2009, then increased in brightness by about 100 times in 2012, before decreasing again. Now, scientists are waiting to see if the IMBH will flare multiple times or if it will continue to decline until it disappears. The discovery of NGC 6099 HLX1 has significant implications for our understanding of black hole evolution. Scientists believe that intermediate mass black holes may continue glowing and eventually become supermassive black holes through coalescence with other IMBHs. Alternatively, supermassive black holes may have formed from dark matter halos in the early universe. The study of IMBHs is complicated by the fact that space telescopes rarely discover tidal disruption events. However, the newly opened Rubin Observatory in Chile, which looks at a huge portion of the sky each night, may help locate these events for further study. And this is the part that sparks controversy. What if IMBHs are not just rare occurrences, but rather a common phenomenon that has been hiding in plain sight? What if the discovery of NGC 6099 HLX1 is just the tip of the iceberg, and there are many more IMBHs waiting to be detected? The debate is ongoing, and scientists are eager to continue exploring the mysteries of the universe. But we want to hear from you. What do you think about the discovery of intermediate mass black holes? Do you believe they're a common phenomenon or a rare occurrence? Share your thoughts in the comments below. NASA's Hubble and Chandra discover rare black hole devouring a star. What if I told you that astronomers have caught a cosmic predator mid-meal? Deep in the heart of a distant galaxy, a black hole has been spotted devouring a star, a rare spectacle that's sparking debates among scientists. But here's where it gets tricky. This isn't just any black hole. It's an elusive middleweight, a so-called intermediate mass black hole, IMBH, hiding in plain sight. And this is the part most people miss. Why finding these black holes matters for understanding how the universe builds its most monstrous black holes. NASA's Hubble Space Telescope and Chandra X-ray Observatory have joined forces to spot this rare event. Dubbed NGC 6099 HLX1, the black hole resides on the outskirts of a giant elliptical galaxy 450 million light years away in Hercules. Think of it as a cosmic buffet. The black hole, weighing hundreds of thousands of times the sun's mass, has been feasting on a star that strayed too close. But here's the catch. IMBHs are notoriously hard to detect because they don't constantly devour stars like their supermassive cousins. You have to catch them in the act of a tidal disruption event where a star is torn apart by the black hole's gravity, unleashing a burst of X-rays. This particular IMBH was first spotted by Chandra in 2009, glowing with X-rays 100 times brighter than in 2012. Hubble later revealed a cluster of stars orbiting it, packed so tightly that they're just a few light months apart. Imagine a neighborhood where stars are neighbors so close they'd be shouting across the street. This density gives the black hole a steady menu of snacks. But here's where it gets controversial. Does this mean IMBHs are more common than we think, or are we just seeing a rare cosmic feast? The discovery raises big questions about how supermassive black holes form. Two theories dominate the debate. The first suggests IMBHs are the building blocks for supermassive black holes. When galaxies collide, these middleweight black holes could merge, growing into the giants we see today. The second theory proposes that in the early universe, gas clouds collapsed directly into supermassive black holes without forming stars at all. But wait, could our telescopes be missing the bigger picture? We might be biased towards seeing only the most extreme black holes, says co-author Roberto Soria. What if there's a hidden variety of growth mechanisms out there? The challenge? Finding more via IMBHs. Chandra and XMM Newton only scan tiny slices of the sky, making rare events like this hard to catch. Enter the Vera C. Rubin Observatory in Chile, which will survey the entire sky for optical flares caused by tidal disruptions. If we can spot more IMBHs in action, we'll finally answer, how many are out there? And how did they shape the galaxies we see today? So what's your take? Do you think IMBHs are the missing link in black hole evolution? Or is there another piece to this cosmic puzzle? Share your thoughts in the comments, because the universe is full of mysteries and we're just beginning to scratch the surface.